Hello, greetings everyone. Welcome to the IABMAS 2022 event in Barcelona. I'm with Risma Putra Pratama from Directorate General of Highway, Ministry of Public Works and Housing. On this occasion, allow me to deliver a presentation about bridge scouring, inspection, and mitigation in Indonesia. The following is an outline of the presentation. Bridge failure due to scouring in Indonesia has reached more than 30,000 unit collapse, where the data is calculated for the last 10 years. This general condition was obtained based on the result on the manual collection of the National Disaster Management Agency based on reports and information that occur on the field. This condition caused many problems, including traffic jams and disruption of logistic delivery around the affected area. This is compared to provide awareness to us that bridges are the part of an important road network structure. Several bridges in Indonesia are located on the river, a type of river that have high potential to damage and cause the bridge to erode. The types of rivers that have this potential are braided and meandering rivers. And these two types pretty much give a bad record on the performance of bridge in Indonesia. In the last few cases in 2020, there is 3 bridges collapsed at the same time, which occur in one area of the national road section, which was caused by heavy river flows, and all affected bridges are in the same area and causing transportation and logistic obstruction. The 3 bridges are Kosio Bridge, Sinandaka Bridge, and Sinandaka 2 Bridge. In addition, there are about 15 other bridges, some of which are heavily damaged and some other in critical condition. So based on this situation, the Directorate General of Highway require a more detailed guideline to provide an assessment to the condition of the river around the bridge. This guide is prepared in the context of mitigation and is part of overall bridge management system in Indonesia. And these guidelines were officially published in mid-2021, about 1 year after the great disaster occurred. Okay, the several things are clarified in the guidelines. There is the procedure of assessing the condition of the bridge, which starts with determine the type of river, the type of river around the bridge. With this stage of determining of type of river, it's hope that we can be a part to improve more objective assessment of bridge condition. The condition mark is given as follow. Condition 0, there's a condition with no defect. Condition mark 1 is very minor defects. And condition mark 2, and the defects that require monitoring or maintenance in the future. And condition mark 3, the defect which requires attention soon. And condition mark 4 is bridge on critical conditions. And the condition mark 5, the element is broken or the bridge are no longer functioning. To get the condition mark on the bridge, there are 5 assessment components that determine the value of the conditions. There is a nature mark, degree mark, and then extent mark, function mark, and the last one is implication mark. And this is the component. Some of them are made guidelines. There is a S mark and R mark that have been detailed quite clearly to making it easier for inspector to determine the damage occurred in the field. The following is S mark explanation for defect classification of waterway around the bridge, such as siltation and debris accumulation and obstruction, score, and excessive flux. The nature mark is mark S is seen as below. And then the following is the air mark explanation for the defect of classification on the waterway around the bridge. This is there is a criteria of the assessment, and the degree mark mark R is light and heavy. The following is S mark classification for score protection element, embankments, and foundation. The appearance is like missing material, score, crack, settlement, or bulging. And then this is the mark R for the score protections, embankment, and foundation element. Next is the S mark classification for abutment or pier. The appearance is slightly movement that cause overturning, rotation, settlement, and tilting. And then this is mark R classification for abutments or piers. There is a criteria for assessment like rotation, a settlement, or etc. The following is the conditions of bridge that affect by score that needs to be considered. The first one is the vortex around the bridge pillar, and then the exposed foundation of the bridge pillar and abutment, and then score hole during dry season inspection, and then the collapse or score in the riverbank around the bridge. With some conditions that have not been well described in the inspection report, then several improvements have been made to support the assessment of the bridge condition to make it more accurate. That is the collection measurement of river topography data around the bridge location, which includes the cross section of the river equipped with river contour drawing. And then collecting data on the gradation of riverbed material around the bridge. And then collecting data on existing and future activities around the bridge site, such as sand and rock mining, cut and cut-off, bridge construction plan, micro hydropower development plans, and so on. Next is analysis of river morphology related to the change in the riverbed in the vertical direction. And then identification of meandering river behavior that has the potential for scoring hazard around the bridge. So that the analysis of change in a river morphology in the horizontal direction is required. And next is analysis of local score due to bridge pillar. And then calculation of the potential for local score that occurs around the bridge. And the last one is to determine the determination of alternative or anticipation and countermeasure against local score hazard they may occur. The following is the supporting tools for detailed inspection of bridge, such as total station, ruler for water level, digital camera, stopwatch, sediment grab and probe, and current meter. And the following is spatial tools that determine the depth of the riverbed to the river water level with photometer for echo sounding, back sediment sampling, and drone for mapping the surface of the river. To fulfill the need of photo of the river condition, one of the techniques to support a more objective assessment is to use a drone that's set to fly in a certain path and altitude to be able to take a picture of the top view, which will then be displayed, processed using software, and the basis for analyzing field condition. The photo taken from the drone is then proceed into photogrammetry to generate 3D data utilizing sparse point cloud technology and dense point cloud processing, which will later be converted to counter analysis. And several conclusions can be drawn from this study that the explanation of river condition transversed by a bridge is important in determining rounded value of the bridge conditions. And the error in conditions assessment can have a negative impact on the road system operation. The last one, with this existence of a river conditions assessment guideline, can facilitate the inspector in establishing to better and objective condition assessment. Okay, that's all from me. I apologize if there is shortcomings. If you have any question, you can send them to the email address below. Thank you.